All right, so now we're going to move on to section 3. We're still in section 3.3, but we're now going to move on to what's called standard deviation. All right, it's really not a hard thing to calculate. It just can take a few steps, and it's easy to maybe get mixed up with some of the steps. But this is now going to really help us to answer our essential questions. All right, there's just one section or one question that we're doing in this video, and that's it. All right, so when we're trying to find the standard deviation, the first thing that we need to find is our mean. All right, so when we find our mean, we add all these numbers together, and then we divide by the total number that we have. So when we add all these up and we divide by 6, it's going to be equal to 35. All right, so we've already learned how to find our mean. All right, then we're going to create this chart, this table. Right, in this first column, it's going to just be all of our values, and we're going to refer to these as X. And what that is, it's all of our values that we found to get our mean. All right, so all of these are considered our values. So we would write this first, so it will just be, it doesn't need to go in any specific order, but 10, 60, 50, 30, 40, and 20. So the very first column is just all of our values that we're dealing with X. Our second column is going to be our X, or all of our values, minus our mean. So that means this first number here, I'm going to write it small, it will be 10 minus 35, or the value that we have then is negative 25. All right, the value for this one will then be 60 minus 25, or the value that we would write is then going to be 35. All right, so you're going to fill in the rest of your chart. So let me pause the video and fill this in. I'm sorry, I just realized I made a mistake now. It's 60 minus 35, which is then going to be equal to 25. I'm sorry. So remember, it's minus our mean. I don't know why I was doing 25, maybe because the number above it was 25. So this would then be 50 minus 35, which is then going to be 15. All right, so here it is filled in the rest of the chart. 30 minus 35 is negative 5, 40 minus 35 is 5, and 20 minus 35 is negative 15. All right, so now after we get those values, we're going to take the value that we had there and square it. So that means this is going to be negative 25 raised to the second power, and that is going to give me a positive 625. So this value here in this column will always, always, always be positive. So then this one will then be 25 squared, which is then also a positive 625. All right, so let's just go ahead and fill in the rest of that column. All right, so that is filled in the rest of our column by just squaring the difference of our value and our mean. All right, then we add all of these numbers up. And when we add all of these numbers up, that will be equal to 1,750. All right, so we find our mean as step 1. Step 2 is we write down all of our values. Step 3 is we subtract our values, or our mean from our values. Step 4, we subtract our value from our means and then we square it. Step 5 is we add up all of those values. All right, then the next thing that we need to do is we need to divide by the total number of values that we have. So we have 1, 2, 3, 4, 5, 6 total values. So we need to then take that 1750 and we divide it by 6. And 1750 divided by 6 is equal to 291.7. All right, this is referred to as our variance. So we're going to learn and talk about this in more detail later on, but that is called our variance. Our standard deviation, which has the symbol that looks like this, is we need to go ahead and take the square root of that. And the square root of 291.7 is equal to 17.1. All right, so that is our standard deviation. And what this standard deviation tells us is it tells us whether or not our data is close to our average or far away from our average. So the bigger the number, the bigger the standard deviation means the further our data is away from our mean or from our average. The smaller the standard deviation means our data is closer together. So we want to have a small or a low standard deviation if we're doing some sort of test. That tells us that most of our data is close together. All right, that is it for this video.